before we get into the panel, of course, the panel has three eminent researchers from possibly three generations itself. Professor Hema Murthy, like a possibly like a teacher to the Indian generation today from IIT Madras, and Professor Mitesh Khapra. I have taught, of course, Pushpak student, and of course, I have opportunity to co-teach a little bit with him. So I, as a colleague, and also Siva on the next level as a student. We have three generations of people with from different parts, and two of them are online, and Professor Hema is here physically. So before we get into the topic, I think I want to remember a couple of things which connects me to this panel, to this theme, to the Professor Sangal. So I joined the IIIT in the late 2000 or December 2000. By then, I was possibly one of the early faculty members, and by then Professor Sangal and his team was here, and they were doing language processing. I think maybe in the first few days after joining, I met Professor Sangal, and in his usual style, very politely, he introduced himself. He talked to me, what do I work, this, that, etc. So he told me that, look, Jawahar, there are some students who want to do some character recognition. Can you please guide them? So I got 6 students to guide in the first week of my joining here. I think possibly that was my introduction to how to work with large teams of students. Not only that, the character recognition was too far for me at that stage. I was more of computer vision or image processing, pattern recognition person. I did not even care about character recognition problems. When IGDAR was happening in 1997 in India, that's on the occasion where this happened in Bangalore. I was in Bangalore, but I did not go for IGDAR. So it was my introduction to this new area of character recognition, OCR, handwriting, scene text. And today I am on the advisory board of IGDAR. And so I can see the journey where it started and where I am today. And I think I want to extend what Professor Pushpak mentioned a little before about multilinguality. Multilinguality, from of course, there are a lot of perspectives on why one should work on multilingual and why is it important for India type of thing. But a very engineering perspective of multilinguality from a deep learning perspective is multilingual models are better. They enjoy data available in different languages and possibly do better. In the last month, I was in CVPR, the top computer vision conference. And one of the very important or simple message that I got is possibly that multi-model, the models are going to work better than single modality models. For the foundational models, which are multi-modal, where speech, text, vision, language, multi-modal, is going to work better than the single modality. Interesting perspective. Okay. So I see the new modality process Sangal at that stage. I remember when the language was mostly text at that stage, he insisted on having speech people. I think that's the time where Kishore joined the group from IIT Madras. And he wanted to have OCR style of activities connected to the language. And I can see where that entire effort is going today. So I want to still bring a little bit more powerful connections with Professor Sangal to the theme of deep learning. Where, like, when I joined, I was teaching programming. I think Siva may be the victim of that in that batch. So I was used to teach programming in the initial years, and the fight used to be like a programming as a practice, or the programming as a problem solving, or applied algorithms, or the drone style of programming, which I was a champion of, versus can you prove the correctness of the program? Another strong school of programming which existed and which exists. And this every now and then, whenever I never realized actually this debate when I agreed to teach programming, and then suddenly I realized I got into this trouble as on one side of the story, and I was a proponent of that. But what surprised me at that stage was Professor Sangal had a still very interesting thing that he brought in, a new word which got into my vocabulary, that was powerful. He used to bring a set of courses, which at that stage it was called IT Workshop 1, 2, 3, and now it has changed the name in IIIT, and possibly the name has gone too far, where he used to argue that a student should be taught MySQL before the student learned database. A student should be taught socket programming before the student learns network course. And then he connects this to the practice theory, practice hierarchy of practicing and then learning the theory and practicing. I think the deep learning tools perfectly fit into this paradigm today. The practice, it allowed the entry barrier for research or the powerful tools or training or machine learning or deep learning or problem solving much simpler, democratizing this sort of development with a lot of open resources and making a lot of things like curious people to get into the core areas, solving problems, and creating the curiosity in people who want to spend deeper, who want to go deeper, and solving problems in a more principled manner, and possibly still going to the next level of practice. Possibly a perfect way to look at how the undergraduate research or the research at this level could be designed with the sort of tools that we are seeing everywhere. And we are seeing it is disturbing or disruptions in the different research areas in different forms, positive, negative, concerns, and utilities. We are seeing both sides of it every day in our the interactions at different places. So that's my introduction to this space of deep learning or language processing, or why am I here. This, I think I would like to invite the panel members to share their views on the main theme of this, that is on the deep learning. Can deep learning be silver bullet for language technologies? But as a first round, let us listen from the panel members on what they perceive as what has happened in the recent past and what they and possibly expect to happen in the near future, or recent past and near future. What do they think what is going to happen? We should come back into what is lacking and what more is required as we move forward. So let us request the panel members to speak a couple of points on the past as well as future and what they think about that. I'll start with possibly Professor Hema Murthy first. Microphone will work.
Can you hear me? Hello. Yeah, I don't know. I have mixed opinions about deep learning, and I went back and looked on the web, the silver bullet meaning, and it was believed that the silver bullet is required to kill the werewolf. Werewolf. Okay. So if werewolf is your target, maybe silver bullet is enough. But when you're looking at something that you do not know, the coronavirus, for example, is silver bullet the answer? These are questions that we need to ask. So our goalposts keep changing from time to time, and what we need to solve changes. And in my opinion, I remember we started out with, I remember the first speech recognition system that we built was a character-based expert system where we actually looked for characters. I mean, again, as student Ishwar worked on this, and we had solutions then too for the small amount of compute power that we had. Then we went on to classical machine learning, and then we found rule bases were very difficult to learn. You had thresholds on all kinds of things. If then rules, too many rules. But the important point was at that time we thought we were doing AI anyway with 640K of RAM and 20 MB hard disk. Then we went on, classical machine learning came. We got 1 GB of RAM, and we said, okay, I can build classical statistical models. I define a structure for the data from what I understand from the physiology of the signal. I worked with speech, I worked with music, I worked with brain signals, I also worked with network data, where I applied some kind of machine learning. Statistical learning is what I would like to talk about. And then we did with 1 GB of RAM, and we did with 500 MB hard disk, which was a big thing in those days. And now today we are into terabytes, GPUs, and even then we had the vector process, which would do. I mean, I used to do a lot of spectral computation, so having vector process is very important for us. And then we moved on. Now we have the GPUs, and we have the CPUs plus GPUs plus hard disk and RAM. So, as Jawahar had said, yes, surely deep learning to some extent has perhaps democratized, you said. I wonder whether it is because the recipes are available today. During our times, we didn't have recipes. We wrote every recipe that we needed. So I do not know whether we need to go back and revisit some of those paradigms, make changes. Maybe you are we using a machine gun to shoot a fly sometimes? Do we need maybe very simple models? Maybe I just need to refactor, just as you have beautiful recipes in your, whether it is PyTorch or whatever it may be. Are there, if you revisit, maybe you will get something even more. We don't have to ground the environment. That is my way of looking at it. Another thing that we have also been doing a lot of deep learning in the last few years at IIT Madras. And one of the things that I've really felt does not matter whether it's classical learning or deep learning, it is simply learning structure in the data in the form of a statistic. In one case, you parameterized, you defined what the parameters were. In the other case, it's finding this parameter on its, finding the parameterization on its own. And I like this example which somebody gave to me some time back. When you use the Newton-Raphson method to find the solution to a nonlinear equation, then we say, let us give the solution close to the actual solution. It will converge very fast. We'll get the solution very quickly. Here, what do we have? We have the data which are the solutions. We are trying to find that nonlinear equation, that nonlinear representation that is there. So now I think it's really very important as we are beginning to see more and more clear. I think even Andrew and G talked about it in the spectrum talk or whatever it may be. You need smart data. You need authentic data. Does not matter whether you deep learning, you do classical machine learning, or you even build a rule-based system. That cleanliness, authenticated, curated data is extremely important, whatever be the paradigm. Now, one of the things that I am going back to what I've been recently working on text-to-speech synthesis. I already mentioned to Pushpa. So for speech recognition, I may be a little biased about this problem. They say, oh, TTS is very easy. That's what people tell you. When you do ASR, you give a word error rate. And say, okay, so many words in error. People don't think about it. If I have, let's say, 10% word error rate, that means I'm having for every 10 words, 1 word in error. How useful is such a system for the user experience? Similarly, with blue scores, when we are struggling with 25%, 40%, I think somebody said we need to revisit the definition of these scores itself. In TTS, unfortunately, it is 0%, whatever it may be. You cannot have even a single syllable in error. One syllable in error, and we have done these mass evaluations, and you think, oh, the entire sentence is almost good. One syllable wrong, and you'll find the user is rated in 0. We don't allow rating of 0. We give rating of 1 because if you use a multiplicative mass, you can get into trouble. So this is something that we have realized. And more, as we are building conversational speech synthesis systems in the deep learning framework, we found that accurate labeling really matters. The more accurate, for example, I think you used our data for Marathi speech synthesis. Bhaktyansh uses Marathi data, our data, primarily because it's highly curated over some 5 or 6 years, where we have actually labeled at the errors are something like 30 milliseconds or some, not even that much in the labeling of the sound units that make up. And in the context of end-to-end speech synthesis, we have actually found that after when Google said, you need 50 hours of data for speech synthesis, we've been able to show with highly curated data, 5 hours it actually begins to saturate. 10 hours is more than adequate. And the systems converge really fast. So my takeaway is that all these are statistical machine learning techniques. And I will say damned statistics, sorry for using foul language, but that's what it is all about. And we need to get the expertise of the human. I mean, I work with brain signals, I work with speech, I work with music. Everywhere we have found when we get to the expert, then we know what it is that we need to look for. It will always find it. I don't know, Professor Jawahar, really remember when MIG came down, he asked us to analyze the data. And we thought the voice of the person in the cockpit, we thought it was actually the person who was connecting to him, we thought that was the voice of the person in the cockpit. Then finally he brought us the person from the Air Force. I said, no, this is not the voice. The other voice is what we should focus on. So there is always some expert knowledge which you incorporate. Doesn't matter whatever the classical machine learning, rule-based, deep learning, I think benefits tremendously. What he has said, having recipes available has made life easy. So is it that we need to go back and revisit and do good recipes so that anybody democratizes just as we are talking about? So this is my take on deep learning. Thank you.
Thank you, Professor Hema. Now let me go to the online. Let me request Professor Mitesh to make his remark on what he looks primarily on the past and future.
Thanks, Professor Jawahar, and it's an honor to be here and to be a part of this event celebrating Professor Sangad. So I'll start with my comments on what I think about how the past 5-10 years have been, right? And what is it that deep learning has brought in, which is something unique to it, right? So I'll for a second talk about the well-known things, which are, I think Professor Jawahar already touched upon that, which is this reducing the entry barrier, unifying these modalities. Now it's very easy for someone who works in text to adapt things in speech and quickly get expertise in the speech models that are there today, or even the vision models there are today. Right? They're all very unifying architecture. So those advantages are, of course, there, right? But two things that I would like to point out, right, which I find interesting, and I think of it as a significant contribution of deep learning, is one is this bringing data to the forefront of research, right? So now if you look at it 10 years back, if you're someone who's building data sets, there was not much recognition for that, right? You could never get a published paper in a top A-star conference just by building a data set. Right? There were separate conferences which were not perhaps treated so well, or there were workshops in which you could publish this paper, right? But now with the promise of deep learning, that if you create a good data set, you can actually get high performance on tasks which were otherwise considered to be hard, right? And these includes things like question answering or machine translation or even TTA speech and other tasks, right? That has created a lot of incentive for creating these data sets. And now almost every top level conference has spatial tracks, well-recognized tracks for data sets, and they're treated as par with other publications, right? Now, what is the effect of that? So I don't know whether going forward, deep learning will be the silver bullet, or will we ever have a silver bullet? I don't think in the history of NLP or machine learning, there's ever been a single silver bullet which has solved all the problems. Right? Perhaps that will not happen. But this interest that it has created in data sets, and as a result of that, the flurry in creating data sets, all the wonderful data sets that have been created in the past 5-10 years, they will last for a long, right? And they will continue to drive research long after people move on from deep learning, right? Irrespective of what statistical methods we use, the data sets that got created because of this deep learning wave is what will last for a while. And that's one thing which I find is a significant contribution of this deep learning madness, right? The other is to bring engineering to the forefront of research, right? So now if I look at it 10 years back, 15 years back, when I was doing my PhD, the kind of experiments that I used to run are quite embarrassing in comparison to what students today do, right? Even say master students or undergrad students, the engineering effort required to take a 1 billion data point data set, make it to run, serialize it, make it sure that it runs on your memory 32 GB, it fits in that. If it doesn't fit, how do you take two nodes and then make it fit? How do you do data parallelization, model parallelization? Right? These are all core engineering issues, right, which students are learning about today. Right? And this is an important thing, right? It kind of bridges this world between academia and engineering. Right? Traditionally, I mean, whether we accept it or not, people do think that there's always this thing about academic code versus or research code versus production code, right? And there's this gap between the two. But now with the availability of these frameworks and this emphasis on getting good engineering skills, otherwise you'll not be able to train or run the models at scale as the deep tech companies of the world are doing or the top research groups are doing. And so that is kind of forcing students to get better at their engineering skills, which I think is a positive outcome of deep learning. So I'll just stop here with these 2 points, and of course I'll come back and talk more about specific questions.
Thank you, Mitesh. Let me now go to Professor Siva. Your comments.
Thanks, Professor Jawahar. Are you hearing me well?
Yes. We can hear you. Well.
Yeah. First of all, thanks for inviting me. It's a huge honor to be here. Just in a few words, I want to tell my relation to IIIT and Professor Sangalji. So I did my undergrad in IIIT from 2005 to 2010, and also switched to dual degree program from my BTech, and that's where I did my thesis in LTRC. And I have come a long way since then. So my roots of my success, I would say, are I would entirely credit them to Professor Sangalji. The reason is that he believed undergrads can do research. And Professor Jawahar also mentioned some of these points, ITWS, and there are these projects where we were able to work with many research groups, LTRC for one, and that paved me way to work with exciting research problems early on, and that that gave me an opportunity to explore more and more NLP. So I really thank Professor Sangalji in believing in undergrads and also believing in me to take up this challenge. And not just that, like over the time, I also learned it's not just that research that matters, but also value education, values. So on, I mean, as a professor now, I realize some of my time, like to major extent, goes to spending my time with students on these issues like mental problems and so on. So thank you for giving me that skill set. And going back to the question of the past and present, we should. I'll first talk about the success of deep learning, which all the panelists mentioned. So the elephant in the room here, I think we all are aware of, is large language models, and what has it enabled? The most fascinating thing is democratization. Like anybody who doesn't even know much about NLP can actually make use of these models. For an example, you could look at this technique called prompting, where you can actually talk to a large language model to try to do the task for you. A task like sentiment analysis could just be one line of code, and that line of code is nothing but a natural language sentence. And that could be something like, hey, language model, can you give me the sentiment of this sentence? And you may provide one or two examples, and then you leave that to the language model to understand what the task is. Everything in natural language description, and imagine the possibilities of this. So I have also been interacting with many industry folks, and these techniques are being widely used by non-NLP experts. Anyone who can speak a language can now make use of NLP technology. So that's fascinating. And so the other thing I also want to mention is we went so much far just using language itself, language data itself. But one, we should also understand like humans are not the same way, right? If you take the argument of non-Chomsky's argument or other people's poverty of stimulus argument, a human child is not exposed to billions and billions of words, and still a human child can acquire language and do really great things with language. And now why do we need that much amount of language? And I think that key missing puzzle here is multimodality. While human child is not exposed to billions and billions of words, they are exposed to billion data points, or maybe unlimited number of data points to other multimodal stimulus like vision, like hearing, sensory aspects. And right now it's very exciting time. Like we have shown so much progress with just using language, and now imagine what can we do if we integrate vision, speech, and other things. You probably have seen things like DALI 2, which can generate image just based on natural language description. And to give you an anecdote, like we worked, my partner Abhilash Numela, he used to work as an undergrad on generating images just using text description. So this was something that we were working back then, even without much clue on how to do this. But now you see, like it's almost incredible. We can see photorealistic image generation. So we have come far away. But that's not the story, the full story. There's also like the dark side of it, right? The dark side of it is the amount, the scale of data on which these models are trained on, and in the context of Indian languages or other minority languages, that's a big problem. So that's sample efficiency is a big problem, which we did not have probably so much with the rule-based methods. Like they were able to, like with few rules, you can generate infinite amounts of data or anything like that, which we don't have. And other thing that we should also warn people is that these models, we don't understand fully how these models work. And it's very, very surprising, like little perturbations of your input text given for a given task can completely change the model outputs. And it is not done systematically. Like we don't really understand why the model behaved in one way for just changing word or adding some meaningless word. The other limitations that we should also be very careful in Indian context is the biases of these models. These models are consuming immense amount of data, and there are several like stereotypes that these models are fed, and they tend to amplify these stereotypes, which is very important. Like these minorities are adversarially affected because of the stereotypical bias towards these particular minority groups. And with that, I will stop. But I am happy to revisit some of these points in detail.
Yeah, thank you, Siva. So I think we have a initial view from all the panel members. I have a very specific question about what we may have to see, or what could be an issue as we move forward. I'll possibly in this round I'll go with Mitesh as a first person. So the question is about, like, so we know that what happened or what is happening today in terms of the success of the data, success of the deep learning models. And I think many of these are going to remain in some or other form. Mitesh also argued about surely data remaining there. Maybe many of the models or knowledge or results out of these algorithms too could remain there. But we also have a lot of knowledge available from the past in terms of, say, the structured knowledge or human knowledge. Now, how these two could coexist or could collaborate better in the future? So one can think of many ways in these two can talk to each other. So if you look at a machine learning viewpoint, people could say that, okay, one could become a prior knowledge and help the data in some form from a Bayesian or some other machine learning perspective. Or somebody could think of as the data-driven models could become extremely powerful representational tools on top of it. The human reasonings or classical reasonings could still survive. Or one could look at this as one may become a pre-processing or a post-processing of the other. So in different ways, these could or come closer also, far more than what we are able to anticipate today. So what can we expect and what we should aim for in the long run or in the short run and in the long run, so that we take the benefit of the existing knowledge experience that we have on language and human knowledge in different forms, representation, and the data and the machine learning that we are seeing on the surface today. So, Mitesh, would you have some insights?
Yeah. Thanks, Professor Jawahar. So this, of course, I'll start with a disclaimer. It's like a very subjective question, right? And perhaps that's the reason to ask it, because I'm sure all the panel members and others may differ in their opinion on this, right? So my perspective as of today is that in most cases, in most of the efforts today to merge these two worlds, right, this powerful data-driven world, which doesn't care about any linguistic insights, right, or any insights about the problem as such, but just throw label data at the problem and solve it, right? And trying to reconcile it with this world, which has this rich linguistic or domain-specific knowledge about the problem, and how do you merge the two, right? In most cases where I have seen this being successful is being in the low data regime, right? So when you don't have enough data, especially for low resource languages, if you bring in some linguistic insights, then how does the data requirement go down? And this has been tried to various types of transfers or learning from one language, pivot-based methods. A lot of these fall largely under this broad umbrella, right? But what I feel, and there's quite a bit of evidence for that once you cross a certain data threshold, these insights from the domain, from the language, perhaps don't make a lot of difference. And that's what, if you look at most of the, some remarkable things, right? For example, even if you look at vocoders like the WaveNet and the more recent vocoders, I am just amazed by what they do, right? They just take a spectrogram and are able to generate such beautiful audio out of it, right? Without being any aware about what is the speaker, the language of the speaker, any of these things, right? So, and same things you see in a lot of these language models, translation models, which are not really talking about parse trees or semantic structure or any of these things. They just throw a lot of data. Once you cross this million data threshold, 3 million data threshold for machine translation, the model just produces beautiful outputs, right? So while I think there will be efforts to continually invest in this merging these two worlds or reconciling these two worlds in the short run, I think in the longer run, the more you invest in data and try to cross these thresholds, which are more and more becoming clear for different tasks, what these thresholds are, where these insights overtake or rather where the data overtakes the insights, right? I think collecting data till you hit those thresholds. And also I feel, right, we keep saying data is expensive and so on, but we kind of don't, at some point we have to realize that or accept the fact that unless you have data, you won't have success. And also not investing in data and relying on things which are beneficial in the short run, but will not last in the long run, because the other deep tech companies, the startups who are working in these specific domains will keep investing in data, and they'll then overtake these short-term investments. So I think with a longer-term vision, we should invest more in data and let the data-driven approaches drive the research. That is a very, very opinionated discourse from me, and I'm sure I'll get a lot of flack for it, but I just made an honest opinion about how I think about this problem. Thank you.
Thank you, Mitesh. I'll go to Siva now.
Yeah, Mitesh has brought up some wonderful points, and I agree. In the low data regime, the knowledge here, the structured knowledge that we already have, the inductive biases that we know about the problem, they're immensely helpful in the low data regime. But as we hit some threshold in the size of data, we no longer see the usefulness of these inductive biases. It's really frustrating. Like myself being also a linguist, like I also have some traditionally linguistics background. And it's really frustrating that none of my linguistic knowledge is able to help these models do better. So I was trying to encode things like dependency syntax, which is one of the biggest themes of LTRC, into deep learning models to build better language models. And I never succeeded with the scale of data, except in the low data regime, or when I give the gold parse, which is not accessible during test time. But what if we flip the our thinking? Where can we use this structured knowledge? So one place where we can use is to create really hard test sets, or these are the things that the model has to pass before we deploy to the wild or anything. So this is where you can create really good test sets using your linguistic knowledge, and this is what we have been seeing. Like if you take things like negation in language, language models, they have real hard problem to understand a word like not. And you can't really know that these models have this problem with a word like not without actually going in and investigating or trying different samples. And I think this is where linguistic knowledge or the knowledge about the task plays a very big role. And the other thing, we know that these models are data hungry, and one way to generate really large amounts of data, which we have been seeing a lot of data augmentation methods, is again injecting all our knowledge in the form of natural language, like generating some synthetic data using our knowledge, and that has been also very useful. The other place where I think it would still be useful is coming up with new ways, new objectives, instead of enforcing our intuitions about about the structure of the problem, like whether whether phonemes exist or not, or one of these. So we could have auxiliary objectives which can be violated when we have the other important objectives. So coming up with multiple objectives to solve the problem, and it's totally fine. Like these are soft objectives in some way to ignore our inductive biases. I think this is where our knowledge plays a bigger role. Yeah, that's my take.
Thank you, Siva. Let's go back to Professor Hema Murthy.
I always go back to this answer that, the brain is 1.5 kilos, consumes 25 watts of power. We have to get there. And, whatever I have read, speech, for example, a child from birth to adulthood maybe is exposed to 16,000 hours of data. And they can recognize languages and so on. Whereas we're using 128,000 hours of data. I would ask the question differently. For a deep learning model to perform well, what is the minimum amount of data? What is the minimum amount of power? What it reminds me of is, I remember I also used to teach programming, and you said, every hour is bringing this much memory and only this much compute power. I think that is a question as a nation we should think about. We cannot talk about 128 GPUs and 1,000 cores, or each core with some 8 GPUs and put all the power in. And each problem, I think we have to look at it. Maybe a very simple classical model is adequate. Something else maybe requires a deep learning model. And as Mitesh said, data, yes, but what is important that we're seeing, especially in the context of speech, is noisy data. We just cannot get it to scale. And we just, you think it will ultimately run it for 2 months, and finally you have a data set for which it doesn't work. Creating synthetic data sets, we've done that for ASAP, but that's still not good enough. There's always the unforeseen that is there. So I feel we have to ask these questions to ourselves. Do we have the power to, do we believe that we have to build technology which is compact in power? India has promised COP26 that we will reduce by 2030 our carbon footprint and things like that. You must remember there's a huge carbon footprint here, and do we really need it? And there, I think expert knowledge can help. I mean, we've seen it in the deep learning context for both ASR and TTS. Let me tell you, one of the big things for speech recognition has been how good is my voice activity detector? And that is hardly machine learning. People use deep learning for it. Finally, a lot of signal processing is used. I always give this example in my class, I certainly believe you have to understand your signal. I will come from this background of speech signal processing. I talk about cricket, and if you want to, you're watching maiden over after maiden over. If I ask you to explain, you will not be able to explain. But somebody gets caught in bold, you'll say exactly third, deep third man, and it just went over the boundary or got caught on the boundary before the boundary. You can explain every frame. And this means non-uniform processing that happens in the brain. None of us ever do that when we look at input signals. Doesn't matter, text or speech or whatever. I mean, yesterday I was talking about, we look at phrases sometimes, we look at words sometimes. So what is the resolution with which we actually process information? I think that's completely missing in any of these paradigms.
Thank you, Professor Hema. I think I can. I have one more question before I open it up for audience to respond. So this round I'll possibly start with Siva. So the question of like what type of challenges that we are anticipating in the near future or coming future. So two important dimensions that we see is one, of course, so we are all concerned and worried about the challenges and for Indian languages. What are the challenges for Indian languages? Second is also about there is a issue with what we can practice today. Say, for example, is it a race and is it a race against the rich corporates? What is the focus in an academia? What should be the focus in industry? What should be the focus at a training student level, at a PhD thesis level, versus what should be the focus of somebody who makes money out of it? So how do you balance what are the challenges in what we are facing today, and how do we plan to address these challenges? That is the next query, and I'll request maybe Siva to respond first.
Yes. So yeah, this is a big problem. Graduate students seeing a paper from industry each day and getting really disappointed. Oh, yeah, NLP solved, or computer vision is solved, or one of these problems. So this has been a huge problem for the whole academia. But I'm still very hopeful of academia and what the role we can play here. So one big thing is right now, you might some of the panelists or other people in the audience, they may not agree that we should really embrace these large models because they're expensive to train, but once you train, there are many uses of those, and the inference of these models is not as compute intense as training. So if it is helping the entire world, training it once or twice or maybe even 10 times is not a bad thing. And the other thing is that there have been so much progress in distillation methods, knowledge distillation methods, where you can compress really large models into smaller models. But coming to like what academia can play here is in industry, there are too many things. They're focused on deployment. They're focused on building large language models. They're focused on their task. But what they are not focused on is interpretability or like trying to understand what these language models can really do, like the mysteries of these language models. Can they explain why they did certain prediction? So there's recent work called Chain of Thought, which is very puzzling. Like hey language model, can you explain me what you did? So that itself can prompt the model to explain what it has done. So things like those, I think we have to understand what these language models do. And another particular problem that the industry would not care is risks of large language models. We know the problems recently with Google and other places where when you're outspoken about issues with the biases and safety of these models, like there have been really bad implications for the people who raise this. So these are one place where, as a society, as a community, we have to focus on actually understanding where these models really fail, the risks of deploying these models. That's very important. And for moonshot, like there are many moonshot tasks which industry would not focus on. That moonshot project for Indian context could be even developing a chatbot for farmers. Like I don't think industry may not care so much about it. These are the things, like we should involve stakeholders, like who are we developing things for, involving them, and this would not be possible in the industry setup. Developing really challenging tasks on both natural language understanding, computer vision, some of these very, very challenging tasks, and try to make progress towards that. There may not be like a lot of interest from the industry immediately, but I'm sure in years to come, there will be a lot of interest. And this is how we came to deep learning revolution, since it has started at places like Toronto or Mila, where like Bengio and the Hinton group, they have been working on language models or deep learning models in academic setting when none of the entire industry or other academic places, they don't care so much. So yeah, like I have a lot of hope in this. I think we should focus on creating really challenging tasks, safe deployment, and embracing some of these models to figure out what is wrong with them. Yeah, that's my take. Thank you.
Thank you, Siva. That supports the issue in the last round. Yeah, please. Yeah, the challenges for academia and Indian language, both the challenges.
I don't know. I always go back to this thing that I think as teachers, as challenges come, we work with the challenges. But one thing is, I certainly feel people completely forget many of the fundamentals and basics. I still do not think there is any. I mean, today I've begun to feel it's like J2ME, J2E. That's where we are in deep learning today. And J2ME, J2E is gone. Then these people are unemployable. But if you had learned your basic programming as a language independent programming, because then you would have adopted any technology that is there. So somehow that basic paradigm of what machine learning is all about, whatever be the technology that is there behind, I think we are forgetting. We also use transformers in speech recognition, and we found it when we were working with the NPTEL data that things are going wrong. Then we realized what happens in text doesn't happen in speech. Speech, I'm not thinking about what I said long time ago. I want to breathe properly and also say my phrases. So every domain, I think we have to find out what is the right architecture in the context of deep learning that makes sense. It's not that I can take, you cannot mix apples and oranges. You have to understand the technology and appropriately apply the technology for the domain that we want. I think that is what is totally missing right now. And so you have to understand what the domain experts are doing. And I cannot say today, I don't need to talk to a computational biologist when I'm doing genome sequencing. No, you have to know what the amino acids are, how many amino acids make a protein. You have to know all this. And in the coronavirus, what is the mutation that happened? At what position did it happen? Mutations happen all the time. What mutations are important? What mutations are not important? Because so many things are happening around. And there are these, domain scientists who have invested so much into it. Can I tell the deep learning model, hey, look for this? And how do I put that information back? Thank you.
Thank you. We'll go to Mitesh now.
First, echo what Professor Hema just said. I think as academics or within academia, we have to focus on fundamentals. So this hit and run research where you take a model, take a task, hit the task with the model and get some results and move ahead. I think that has only so much of a life, right? And even the adoption of these models, we see a lot of people in the industry, startups, other places, right, where you use these models successfully, but they lack fundamentals in understanding what do you do if the model does not work as you expect it, right? So now if you ask questions like, what exactly does the self-attention do in a transformer model? Or once you have the self-attention, why do you need the feed-forward layer after it, right? So unless you focus on these fundamentals, it will be very hard to make progress beyond a point. And that is where academicians should have this niche in understanding these models or technologies better than most people do. And not just that, even try to educate everyone on the importance of these fundamentals, right? And rest away this narrative that if you just know PyTorch and know a bit of Python, and you can just write this 1-line, 2-line code to solve all your problems. So I think that's something that narrative needs to be set by academicians. So that's one responsibility that we have. Second, while doing so, I think we still need to fight in the battlefield where deep learning is being fought today, right? And which is in the field of, or the battlefield is rather about large models, large-scale engineering, building large data sets, robust benchmarks, right? So we won't be able to shy away from that. Otherwise, we'll lose our, I wouldn't say credibility, but we lose our stand, right? Where does academia stand on this, right? So we have to be at par with what the deep tech companies are doing, because at the end, that is what is driving success. I mean, these models are successful, no matter how you define success. These are successful, right? I mean, they are giving you results on the ground. They have pushed the boundaries much beyond what they were 10 years back. And that is not something that can be ignored, right? So we have to fight the battle where it is. While doing so, and this is the third point, we also need to constantly try to change this battlefield, right? So, and what I mean by that is that, so despite so much, I'll take 2 examples here, and despite so much criticism about blue, even today, 90% of the papers just report blue for machine translation, and they get accepted on the basis of 1 or 2 blue point differences over the baseline or the previous SOTA. Whereas it's a academically accepted fact that 1 or 2 difference in the blue point does not say much about what is actually changing in the output, right? Or the other way around also, no change in blue does not always indicate that your model has not improved. So why are we not being able to fix this problem, right? Why are we not being able to change this battlefield? That while you are fighting with big models and large models, why don't we take the onus of defining better matrix and better robust benchmarks, which are going to define the evaluation? And by doing so, maybe we'll be able to create change wherein just having a large model will not perform on a very robust ASR benchmark or on a very robust machine translation benchmark. People will be forced to do things differently there, right? And also introducing the right kind of metrics. As I said, blue, there's one. The other example I had there was, it's been now 5 years, 6 years since we've been talking about explainability, since we've been talking about fairness, green AI, and so on. Why are we not making these as formal metrics on which models should be evaluated? There's a lot of talk about it, right? But even today, how many machine translation papers are reporting the amount of compute that they used? And even if they report, are we penalizing or awarding them in any way? Which we're not doing that, right? So changing this battlefield a bit, if we really think that large models are not the way to go, or the research is not happening in a way that it is, I think academicians should take this onus of defining better methods of evaluating research and defining progress, right? In the absence of that, progress will be defined in the ways that it is defined today, and that would be skewed towards a certain family of models, a certain way of doing research, right? So we have to perhaps change that, right? So that's all I have to say on the role of academia going forward.
Thank you. A lot of interesting insights, observations. So I think I'll open this for the audience. Yeah, sure. Yeah.
Deep learning is democratized. I have a lot of questions about it. It is for the have-nots. It is not for the have-nots. It's only for the haves. I need to have so many CPU, so many GPU machine to be able to try. For the have-nots, what is the thing? I still want to do deep learning. What is it that I'm going to make available to you? I think it's important to. So I disagree with this democratization that everybody gets, provided I have this huge backend resource. It's like saying, during COVID, everybody got access to, you could do online lessons. The point is, do I have a 21-inch monitor at home, or am I having a 5.1 centimeter or I don't know inch smartphone at home with 5 people peering over it? That is the situation in India, and we must realize that we are.
Yeah.
Thank you.
Thank you. I think there are questions from the audience, but I think Professor Sankar has been raising hand for a while. Yeah.
I wanted to ask, what do we celebrate in democracy? There are two parts, two aspects. One, I have a power to vote. Second, I am part of a process of dialogue and I have power to understand. When democracy first comes, we enjoy the power to vote. Everybody has the power to vote. Very quickly we realize that this was a vacuous power, or it led to somewhere which is out of control, for the worse. The other is power to understand. So do we celebrate democracy because we have the power, everyone has the power to vote, and even that can be questioned? Then everyone has the power to stand for election or not. But more importantly, this aspect that democracy is about understanding. It's about dialogue and understanding, and everyone has the power to understand.
Be a participatory role. This must be a participatory role.
Thanks. Sorry. So I have a question to all the panelists, which is not a technical question. So right now in the global research community, the battle lines are pretty drawn, right? Like there's this hardcore, let's just get only the data and the LLMs are the answer to everything side. And then there is like another side, which is viewed as like, one extreme that all LLMs are bad, but some of the people talking about some caution to how we use, how we train, some of the things that Hema mentioned about environmental effect, some of the things about biases, and it seems that I've never in my 25 years of doing NLP, I've seen such acrimony between the research community. And though thankfully it is not like we've not imported it yet into India, and I hope we never will, but I really want to understand from people here who seem to hold fairly different views on the use and the power of neural technology on how can we prevent that happening. If we continue down the path of we don't need domain experts, we don't need linguistic knowledge, at all on one hand, and on the other hand that how can you do anything without linguistic knowledge, where do we meet, and do we need to meet, because this seems to me unique in the language, not unique but like very very strong in the language area, because in medical area nobody goes and does ML because without having a doctors and everybody involved in it. Now, language we think would be my great language experts.
We are not able to hear properly.
Wonderful.
If I understand right, the question is where we are seeing two extreme viewpoints. So one, which is everything in the world can be done with data. The other one, everything in the world should be done with classical language knowledge. Now, where do we meet in between? Is that a question? Yes. Okay. Yes. Yes. So why are we not considering something in between these two? Anybody in the panel want to respond? Panel members?
So
done in 90s, and we are incorporating the same in the end-to-end models today for speech synthesis. And we have started doing, Umesh with reluctance is beginning to use the same thing, even in the context of ASR. So we are beginning to see the benefit. I think we have to be open and say there is benefit for both of them. And we have, whatever it is, I don't think we have infinite resources. We have, I don't know, I feel very strongly about it. Even though we have resources in our lab, I will ensure that the resources are used all the time. But you can't run experiments for which you don't even know whether there will be something meaningful. You will do some analysis before you just, run the script with these parameters with 100,000 of them or whatever it may be. And out of the 100,000, something will give a result. I really do not believe in it, because you should do some, then you figure out what makes sense and then go back and refix your input or whatever it may be. And we have found benefit for that. And I really feel we have benefited a lot. And in fact, we are hoping that we are using the past taggers from reply. Some silly things it does. When you're listening to the sentence all along, you say very good quality. Finally, it's just coming from the vocoder. Okay, when you talk about vocoders, I don't know why we don't talk about the speech encoders, your multipulse, but mixed excited linear prediction, which was a technique used a long time ago. It was very high quality speech, 13 kilobits per second on your phone, and that's what your neural network is doing.
I think Professor Kamal had a question.
So I just wanted to say something about the previous question.
Okay.
Yeah, there are a couple of questions. One is about the cost benefit analysis of this whole deep learning. It is very costly, as Mitesh has mentioned about bringing in some of these metrics about green AI and other things within the context of that. And second aspect is noisy data. We find that most of the I'm doing something on documents. Many of the documents are very noisy in for even doing simple tasks like question and answering and summarization and things like that. So these again, that noisy data again gives rise to high costs. So cost benefit analysis of this deep.
Anybody from the panel want to respond? Mitesh, please go ahead.
So sorry, actually, so I just wanted to earlier respond to the previous question also. I'll just start with there and then come to this question, right? So I think fundamentally there is no aversion to either of these ideas, right? Be it data-driven or linguistically motivated approaches, right? I think what is missing is dedicated fora, right, where you could show the benefits of both or an hybrid approach, right? So current narrative has mainly been around large data, large models, right? And it's becoming hard to argue against that those results, right? You're seeing benefits of in terms of accuracy. As I said, there are other metrics to worry about. There are metrics like inclusivity to worry about, right? If we have these large data models, large data hungry models, then what about the long tail of languages, which will perhaps take many years to get there, right? But those metrics are currently not being used. Similarly, metrics like what is the compute time and so on, right? So those are not currently used. So in the absence of those, performance is a metric, and there it's very hard to argue against these large data, large models, right? Now, if we really want to show that these linguistic insights are useful, again, I'm taking this more from an academic perspective. I think we need dedicated workshops, if not conferences, where we allow for these ideas to flourish, right? And even if there are negative results, publish them. But I tried this. I tried using something which is linguistically motivated, as Siva was saying, right? He tried a few things, it did not work. Now, that will never see the light of day, but let it be published. If there are negative results, let them be published. Let be fora for that. And then slowly, with a lot of negative results, so perhaps something positive might emerge. Right? So that's where I see one way these areas could meet. Right? And I would like to repeat that there is no fundamentally aversion to it. It's just going by what the current results show. That's the first answer. Now, coming to the related question of cost-benefit analysis, right? Now, this cost-benefit analysis, again, I think today is being driven by utilitarian view, right? What is the utility of these models downstream? So if I develop a good ASR system, if I'm a deep tech company, and if I'm going to develop a good ASR system, and if that's going to increase the adoption of my apps on phones, then that's what I'll do, right? All the other costs of collecting data or spending on compute, all of those get amortized once I see monetary value downstream. It might take 1 year, 2 years to do that. But that's what is happening today, right? That's why people are not shying away from investing in these big data sets and in these big compute times, because they know that downstream they're going to get benefits of that, right? So that is something I don't think is that we can control for, or even should be controlled for, right? As long as you're getting societal or commercial benefits out of it, the people driving this will see the cost benefit in their favor.
Yeah. Thank you. We'll take one more question from the hall and then we'll go to online. Yeah, please.
Can I? Yeah. So, yes, a language scientist with an inclination towards a lot of computational aspects, I always believe that human languages evolve naturally, right? So we look at the languages in two ways. One is a competence and performance. Most of our data-driven approaches are on the performance level. Most of the time, we try to model the fallible human language processing. So there is a cognitive side which also try to look at the languages to create the computational aspects to create a model without much errors. Is there any future where we can connect these two models, cognitive model plus this performance model, which might improve in the natural language processing?
Want to respond from panel?
I can try and address that question. Yeah, so I think that question is related to how can we use cognitive science knowledge, or in general, any kind of inductive biases that we know about how language works and so on. And yeah, there. I see inductive biases in different classes. Inductive biases at input-output level. So there might be better ways to frame your problem, just like the way you format your data or things like that. The way you define the task. So that could be one place where you can use a lot of that knowledge. And the other place that we can use is at the objective level, like what are, as I said, the auxiliary objectives introducing. So in cognitive science, we know we gaze at things. So like gazing could be one of those objectives that we are maximizing for. Like trying to have least divergence between how humans look at words and how models also look at words, like aligning attention of the model with the gaze, something like that. And the third kind of inductive bias is at the architecture level or model level, or even the technology level, like maybe deep learning, not deep learning, but something else. So there, we know in cognitive science, we know that there is modularity in human brain, and in the neuroscience world, like it's very clear that the modularity, and even in cognitive science, we kind of understand there are as humans, we don't try to learn everything from scratch every time, or even when we try to transfer, we learn skills. There are several skills, and we keep reusing some skills for a given task, and some skills we may not be using. So that kind of architecture that focuses on modularity is one way to go ahead. So I think if we frame these problems, the insights that we have from cognitive science into one of these aspects, inductive biases at input, at objectives, at the architecture level, then that could be much more fruitful. Thank you.
Thank you, Siva. I think Professor Pushpak want to add a couple of points to that.
Yeah. So thank you, and thanks to Parameshwari for raising this point. She actually, it's the main part of the debate. The linguist versus experimentalist debate is actually the performance, competence and performance debate, actually. Okay, so performance refers to the universals of language, and competence refers to universals of the language, and performance refers to the parameters in Chomsky framework. So when we train deep language models, deep learning models with language data, we are actually on the performance side. And if we use, let's say, use the modern parlance, meta learning and so on, learning hyperparameters, then we are proceeding towards the competence side of the spectrum. So this debate is actually the competence performance debate, and I think it requires the understanding Chomsky framework well. Okay, it helps us, and possibly people trained in linguists can ask these questions, and these questions are so important. Okay, so this is very important, and this many of our problem with the data-driven approach is not with the data, but with the people who use the data and create models. Okay, so their enthusiasm, and in fact, I also belong a lot to that team. Is very well placed. Okay, I like it. But the importance of analysis, insight can never be done away with. Okay, so this performance competence question is really the main point.
Thank you. I think we'll take a question from online. Karan Singla.
Hi, I work with Srinivas Bangalore, and he earlier talked about virtual agents. And when we are in virtual agents, we talk. Like how we describe. When I tell somebody my name, I'll be like K as this, A as this, R A, so that I clearly convey my entities. And I found that when we are doing transcription, for example, for end-to-end ASRs, instead of transcribing K as this, A as this, one can directly transcribe K-A-R-A-N as Karan. And the ASR itself can understand this and do this inference in the process, how we humans do it. And so the idea becomes, when we do get data for transcriptions, it would have been better if we transcribe how we understand. And that kind of jump is something you don't see until you try it, until you follow intuition and try it. So how do we measure when we are doing a deep learning experiment and doing data collection on getting data which for a task which is data in a way in which it's visionary, it stays, has a shelf life.
Anybody want to respond from the panel? Mitesh?
So can you just summarize the question? I couldn't hear everything clearly.
So the question
Jawahar,
is, the question is,
I'm not able to hear you properly. That's why I was requesting Professor Jawahar to summarize if possible. I can hear him properly.
So the question is, am I clear?
Yeah, go ahead.
So the question is, you can speak to the automatic speech recognizer in a conversational way where you use conversational cues. And they can be use of metaphors, they can be use of expansions to give your name clearly or email clearly. Now, instead of transcribing, doing the literal transcription, you directly capture your transcribe the email itself or the name itself. And I found it's better than doing transcriptions, and machine can do it. But that was cognitively a jump for me, thinking that ASR can do this inference on the fly from speech. So, but in terms of data collection, we haven't been doing that. So that becomes a problem which we should solve in the ASR research itself.
Okay, I still don't think I fully understood.
Is there a different way of transcribing which is more effective?
Yes.
What we do.
Yeah, similar to what humans, in the way humans understand.
Sorry, I'm not getting the answer clearly. I'm unable to answer this. Sorry.
Yeah. Okay. Anybody else want to respond? I think if I understand right, the question is there a better way of transcribing or annotating for that?
Yes, we should transcribe in the way we understand. And we didn't know that machines can do it.
Yeah.
Yeah.
You do respond. Yes.
I don't know whether we have any representation. I think you're asking for Hello. Yeah. So are you talking about representation in terms of what is a message? Because it's believed that message is represented as 50 bits per second, but speech comes out at some 50 kilobits per second. Is that what is the actual message that's being conveyed? I don't think we have a representation of that. If you think about how humans understand, we don't.
Yes.
We don't have any models for that.
Yes, but in terms of ASR, we have been representing the character and the phoneme sequence. But instead of doing that, machines are capable of directly doing the inference also. That's the point I'm making. So we should. Yes.
Inference, I don't know. I mean, I really don't know. See, ultimately, it has to learn some representation, right? And that representation, you're teaching it to learn. So who is going to give that representation to the machine?
So there is no hard signal for that. Machine can figure it out can learn it from as a single neural network.
Yeah. So I don't know whether, we don't know at this stage how to do that. Maybe. Yeah.
I have a paper draft I've been working on. We can talk about it.
Yeah. Okay. Thank you. So we had an exciting session. A lot of questions, a lot of curiosity. I think there are a lot of questions possibly left out. Maybe we'll do it over lunch. We'll miss the online members for the lunch. We wish you are also here. And thank you all the participants in the hall as well as online.